Good morning, good afternoon, good evening, everyone. Welcome to our Building Real-Time Leaderboards with Tinybird session. This is a workshop type format, although definitely also a coding session. And as the subtitle indicates, it's also my attempt to provide 60 minutes to help you get started with user-facing analytics. My name is Jim Moffitt. I'm a developer advocate here at Tinybird. Here live from my basement in beautiful Colorado. I got my cup of coffee and one of my favorite Tinybird shirts, so ready to roll. So let's talk a little bit about what we're going to be doing today. I'm going to spend a little bit of time introducing the whys of user-facing analytics. We're going to tour some example use cases. Throughout this discussion, we'll be talking about common patterns of what it means to build user-facing analytics. And of course, we're going to build a leaderboard with Tinybird. So there's some resources available for today's session. One, there is a GitHub repository set up all around this session. It's out here on our Tinybird CO GitHub account. And what this has is two things. One, it has all the code, the Next and JavaScript code that we use to build the demo that we'll be showing towards the end of this session. But also equally important, it has the Tinybird data project. So in here, we have the actual code, the SQL that we'll be building. So just keep in mind, if you get behind or if you want to, check out in more detail what we're working with today, this is a good place to do it. Also, we're going to be building a leaderboard for this game, for the classic Flappy Bird game. We have our own instance of it, and we'll be building a leaderboard for that. If I open up, there is a repository for this implementation of the Flappy Bird game. Highly recommend checking this out. This has everything you need to run the game locally. And this game, as we'll discuss, has some examples in it around personalization and has a leaderboard, which we're going to update today and come out with a version 2. Also, last Thursday, posted a blog post about this topic. Here it is, Building Real-Time Leaderboards with Tinybird. That title may sound familiar, but if you haven't read this, or especially if you're new to user-facing analytics and why you'd even want a leaderboard in your application, this is a decent resource to check out. So let's talk about what is user-facing analytics. And this is really the fundamental pattern of user-facing analytics. What you have here is, of course, a user-facing application. This could be a web or a mobile application. And it's publishing events to a backend listener. And these events are commonly like click events, indicating items that have been viewed. Maybe they're usage statistics, maybe they're game events, app configuration updates, what have you. So any app event of interest that you want to analyze. So those events get stored and retrieved from a data layer. Typically, this data layer supports things like SQL or some other type of querying language to analyze the data. And also, there is an API layer that the user-facing application, it uses it to request data and its analysis for rendering back in the app. And all this has to happen in real time and be able to serve a high level of concurrent users. And before I move on, this is a great place to highlight that we now support JSON web tokens that enable you to make Tinybird API requests directly from the browser without the need for any middleware or additional backend services. If you are a front-end web developer, be sure to check out yet another blog post we put out about a week ago, actually on June 3rd. But this will lay out the reasons why this is such a great new addition. And if you're a front-end developer, I'm sure you know that whole story already. And by the way, the leaderboard demo that we're going to be building today is based on a demo we put out for this blog post that implements the way of signing these new tokens. So what is user-facing analytics? Part two. There are really, here are the fundamental characteristics of successful user-facing analytics. And there are really two main components. One is data freshness. How quickly are you capturing that data, and how quickly can you use it, analyze it, and display it after you first receive it? We also talk a lot about latency. How fast do the queries return your analysis, your insights? Real-time systems like this require millisecond latencies for queries. And again, with click events, often you have data stores that are, millions and billions of rows. So it's really important to pick a tool that can execute and do this analysis in milliseconds. Another important tenet of user-facing analytics is the capability of serving hundreds or thousands of concurrent requests. We refer to this as concurrency. Another important aspect is the ability to do complex queries. We're talking about joins and aggregations and filters. We want to do, you might need to do complex transformations, and you want to pick a tool that offers you that ability. And also historical data. Historical data is important because often your customers or internal stakeholders may want to compare patterns, maybe from a month ago or from a year ago. So the ability to include historical data in your analysis can be quite important. Some systems you may not care to store data that's more than even a couple of days old, but we find we have a lot of customers, and like a lot of us, we like to hang on to our data. I'm in that camp. I find seasonal patterns always interesting, and having that data readily available and able to pull in quickly is important. And the challenge of doing all of this in real time for thousands of users, and that is the challenge, serving hundreds or even thousands of concurrent requests. So let's talk a little bit about some examples of user-facing analytics before we jump into leaderboards themselves. We have in-product dashboards. These are very common. We have many customers who have built dashboards into their customer-facing app. One top example is Vercel, providing their customers with real-time, up-to-the-second product and resource usage, and really how that translates to customer bills. In fact, we're having a session on May 20th focused on building real-time dashboards. I imagine we will highlight a feature we just released called Tinybird charts that make it super simple to build charts and generate the JavaScript code for hosting in your app. Another common piece of user-facing analytics is real-time personalization. This is your opportunity to customize your user's journey through your app. Our Flappy Bird game has an example of this, where players can receive a coupon to make the game easier. Another area is fraud and anomaly detection. This is a critical area that many of our customers have used Tinybird for. I recently recorded a workshop on building anomaly detection methods in Tinybird, from sensor timeouts to statistical patterns that stand out due to z-scores and interquartile ranges. So if you have an interest in anomaly detection, highly recommend you check out that recording. Again, the fundamental pattern for all these examples are: you capture data about user interactions within your app. You send that data to the analytics platform. You build data views that are then served back to the user as dashboards or other features. And leaderboards are another example of user-facing analytics, and we'll be focusing only on those for the rest of this workshop. So before we dig into the leaderboard details and start building, I just want to take a few minutes to give you some background context about what Tinybird is. I imagine we have some viewers who may be brand new to Tinybird and are still figuring out what we are all about. So first, Tinybird has an OLAP database as its data layer. ClickHouse brings three important features to Tinybird. We've integrated ClickHouse as our data layer, and one of the things it brings to the table is the ability to ingest massive amounts of data in real time. ClickHouse was built from the ground up to work with real-time data, to work with streaming data. Also, it brings the ability to serve thousands and thousands of concurrent connections and requests for data. And this has been kind of a traditional bottleneck with a lot of legacy type data stores, but it largely goes away when working with ClickHouse and Tinybird. And then third, ClickHouse provides an additive SQL dialect, including a large collection of SQL functions and clauses that make working with real-time data more convenient. We'll see several examples of this when we start building out the leaderboard. Another thing about Tinybird, it's a data platform for unifying data sources. Blending batch data and real-time streaming data is a very common use case, essentially enriching these data streams with related metadata. It's a data analysis platform. With the power of SQL and this dialect of SQL from ClickHouse, you can, of course, filter, aggregate, join, and transform that data using SQL, which I imagine nearly everyone in this audience knows. So that's a real win. And also, finally, a place to design and deploy API-based data products. Tinybird is used to publish high concurrency, low latency data APIs. And these APIs are a powerful and standardized way to share transformations created in Tinybird. And you can build these, what we call pipes, and deploy them as fully fledged and documented data products. So you write the SQL, you publish the query as a dynamic API, and share it with other stakeholders. This is another view of what Tinybird is. This is an architectural schematic of a real-time streaming system with the classic publishing and subscribing patterns used with things like Kafka streams. And here we have a data source that's generating events, and an event bus is there in the middle, managing incoming data and making that data available to event listeners that then write that data to some type of data store, and then making it available for SQL queries and analysis along with a publishing layer. So Tinybird abstracts and encompasses the components in this purple box. Here's another view, and kind of updated to what we're building today. We have players generating game events. Those get posted to Tinybird. They get sorted and ranked with SQL and published as a leaderboard endpoint. And then the game instances request that leaderboard data and render the results locally. So, and then let's take a quick tour of leaderboards. These are some examples just captured from out in the wild on the internet. You're probably familiar with Hacker News. They use a combination of factors to rank stories, but the core algorithm revolves around upvotes and downvotes and the freshness of the post. Another example I love is from Strava. They have group leaderboards. These are live. You can set them up. They are based on weekly accomplishments. And it's just a neat way to stay engaged. I myself am very data driven. So if it wasn't for Strava, I don't think I would bike as much as I do. This is sort of a funny example. I apparently have been into leaderboards for a long time. I was at Twitter for a long time, and back in 2019, myself and a colleague built a live leaderboard for what's called a shotgun scramble golf tournament in Los Angeles, California. And this was powered by Twitter DMs and webhooks. So team captains could report their scores, and we could share the results to all of the 18 teams. So this example is about building leaderboards for specific events. Imagine other golf tournaments, bowling tournaments, what have you. It's kind of a fun way to build a tool for sharing results across an event like this. So what are we going to build today? What you see on the left is, as we start playing this game, Flappy Bird, it already has a leaderboard in it, and that's what you're seeing on the left. What we're building today is a standalone leaderboard, sort of a version 2. Has really the same features, a couple new ones added in, and soon we'll be getting into that. Soon we'll be playing the game. Hopefully everybody will play the game. We have some real data to work with, And if there's enough time, I'll simulate another round of high volume of players and high volume of events. So now let's just add a little more detail on what's going on in the Tinybird side. Here, on the left there, we have different players at different stages of the game. All of them are sending game events into Tinybird. Tinybird is ingesting those and ingesting those into a managed ClickHouse instance. All that data is elegantly handled in real time. We then build these pipes where we're actually just transforming the data of SQL. I don't know if you can read the SQL there. It's not important. We'll be building this live in a minute. But you can see you're just using standard SQL to do a rank. And then we publish those as an API, which the Tinybird game then makes a call for and gets the leaderboard data. Here I want to highlight one thing. This is sort of just like the previous diagram, but what I'm showing here is kind of a pattern that I found interesting. And while I want to build a version 2 leaderboard for a production Tinybird instance, I do not want to prototype in that production workspace, but I do want to build with the incoming live data from that production workspace. So what I'm showing here is these game events that we're about to be generating are going into a separate workspace, which is mainly just a collection of pipes and data sources. But we have one that we consider our production workspace for this game. What I've done is I've shared that data source, the events API data source, with a new kind of proof of concept workspace. So very nicely, I can share the production data source with a separate development workspace. And if you're pondering building leaderboards or any other user-facing analytics feature, you might consider this workspace pattern, especially as you get started. And again, if we have time at the end, I'm going to use a tool we call Mockingbird to create 1,000 players that are emitting 1,000 events per second. And we'll see how the demo goes with that setup. Okay, so this is the URL. I would encourage you to go off and play a couple rounds. I don't know if you're familiar with Flappy Bird. I'm not very good at it, but if you go there, flappy-workshop.tinybird.co, this is what you'll see. I'm going to reload, and you add in your name, and then you can start playing. I'm just going to do like one round. I'm not very good. Okay, so let's see what our leaderboard looks like. Okay, so that's the game. And that's the one we're going to be building with today. So let's go off and build a leaderboard. And again, what we're doing here is I'm going to build a separate leaderboard with a separate web app, but it's all going to be driven by the events that are happening here at flappy-workshop.tinybird.co. All right, so let's go build. Let's go build our first new leaderboard. So what we have here is basically a somewhat empty workspace. I don't have any pipes yet. What I do have here is that shared database or data source that is being driven, and events from the game instance are being shipped into that. I'm sharing it here in this workspace. I have this data source defined for later. Again, if we have time, I'll be pumping events from Mockingbird into that. I can come here. One feature I love about Tinybird is this playground where you can build your queries. I'm just going to go look at the most recent entries in our database, and I do see that, yeah, plenty of people are playing the game. That's awesome. Thank you all. But let's go back and let's start building a leaderboard. So I'm going to create a pipe, and I'm going to call this one leaderboard. I'm going to call it V1. Not V12, V1. This is just going to be a quick and easy one, and then we'll take it and we'll expand upon it. So I'm going to call this first node, and these nodes just contain standard SQL. I'm going to call this one get all scores. And what I'm doing here is I want to pull from the Flappy Bird workshop events. That's our shared data source. And what we're going to do here is we're just going to, and this is going to be the only query where I'm going to type out by hand. You don't want to watch me typing for an hour. But what we're going to do here is we're going to select name as player ID. And one thing too, I can show you about Tinybird is when you're working with these data sources, you can just click on the name, and then here you see that data source. You can see the schema here. So those events coming in have a name, a session ID, a timestamp of the event, the type of event, and then the event, which is we built into the game, we build a way to segregate different workshops, different conferences. So we have this event attribute as well. So let me go back and finish this query. Player ID. I want the timestamp. I want the session ID. I also want what event we're pulling from. We're going to pull from that. I only want the type of event, which is equal to score. The other events are game over and purchase. As you play the game, many of you have probably already noticed, if you play a few games and you're not doing very well, you get this option to like basically get a coupon to slow the game down and make it easier. Let's see what we also want. We only want to bring in events from today's event. So that's been labeled workshop 2024-06-11. Let's run this query and see what we get. Right on. LOL is playing lots of games. That's good. So we have this returning scores from our event database. That's the only type of event we care about. And I'm going to build one more node based upon the previous one. I'm going to call this endpoint. That's just a convention to where you can, if you have multiple nodes and you know you're going to publish one of them, I usually name that one endpoint. You'll see in a minute. It just makes it more straightforward when you go to publish. So we got this endpoint. This one, I'm just going to copy in the SQL. I'll talk through it. So you'll notice that a couple things. We're pulling in some of the common attributes. We're pulling in the count as score. So we're looking across players, session IDs in this event, and we're basically counting how many 1-point scores have been achieved. We're going to order that score by descending order, and we're going to pull in the top 10. So let's run this. And there we see our current leaderboard standings. A lot of people, well, somebody got 16. That's great. So here we have our first very primitive version of a leaderboard. Now I'm going to go create this as an endpoint. You just come up here, you click on this create API endpoint. Here I'm going to publish this last one, and boom, I have an endpoint. I have example usage here. You can see that the payload for this leaderboard is a very simple JSON structure. I got the player ID, the session ID, the event that it's from, and then of course the score. Now I can go out to something like Postman, and here I'm going to just clean up my display a little bit. So here is, let me try this. So here what I've done, I've set up this leaderboard we just published. And actually I renamed it here, or misnamed it there. But regardless, I'm calling this leaderboard _V1. That's the one we just published. And you can see the points here. Oh, I see Taylor Swift joined us today. That's awesome. Welcome, Taylor. My daughter would be extremely pleased. So let's go back and continue our mission. So right here, just with these two simple queries and this simple publishing of the endpoint, we have used these to build a very functional leaderboard. This is updated in real time. This thing could handle thousands of concurrent players. But now we're going to go and build what I'd call more of a production level leaderboard, one that will handle great volumes of data. And also it's going to integrate each user's play into that leaderboard. So if you're not even in the top 10, you will still be listed, and you can compare your results to the top 10. So let's go. Key thing about what we're going to build now is that it's going to be built on or with a materialized view. And that's really important because it just helps you handle very high volume events. Materialized views are efficient because they pre-process events, and when queried, they have already done most of the lookups and aggregations, and then they only have to add on the most recent events onto those pre-processed results. So we're going to build a materialized view here. And I will say, if I've done a couple of workshops on, it's called Kafka to Analytics. If you go back and look at those recordings, I spend about 5-10 minutes just talking about materialized views. So if you're curious about them, that's a good place to get more information. So we're going to build a new pipe here. And I like to give it a name that will remind me later exactly about what this thing does. So what this is going to do, it's going to build a user stats materialized view. And it's going to have just one node. I'm going to call this populate materialized view. And excuse me. And I'm going to copy in the SQL we're going to use to build this materialized view. I'll walk through it. So we're selecting an event, the player, the name as player ID. This is where the materialized view type information comes in. What we're telling ClickHouse under the hood is that these are the aggregates, the aggregations that we want to store their states of as data is coming in. We're storing the score events that arrive, the game over events, the purchase events, etc. We're pulling those from the shared events data source. Again, we're saying we only want to work with workshop events from today, and we're grouping by event, player ID, and session ID. So I'm going to run this just to make sure my SQL's right. And then I'm going to come back in here and I'm going to create the materialized view now. So you click on the node you want to publish as materialized view data source. I want to create this. I'm going to give it a name. I'm going to call it, what am I going to call it? User stats MV. And here are the sorting keys. Right now it's defaulting to event. We do care a lot about that because almost all our queries are filtering on that alone. And then we might be doing player ID and session ID. Or I'm going to leave these as they are. They seem pretty decent for this. I'm going to hit next. And here you have a decision about what data you want to bring into this new one. I don't have that many views. I could do previous and all new data. So even if I had a huge source, it would pull them all in. So now let's create this. And you'll notice down here we have a new data source. And this is all based upon our events today. So now that we have this materialized view, let's go in and create what I'll call our real leaderboard. And rather than version it, I'm just going to call it leaderboard. This is our main pipe. And in this, here, let me click in or include the SQL for this, and then I'll walk through it. We're going to call this first one, we're going to rank games. And let me copy in our query. So what we're doing here is we're using a Windows function that assigns a rank to each row based on a specified ordering within a window defined by the over clause. So here we're looking at total scores. We're looking at, we want them in descending order. We're retrieving basically the row number, and that is the rank. Like the highest one will be listed first because we're doing total score descending. Pulling in the player ID, the session ID. Here's where we tell the materialized view, okay, we want you to merge everything. We know you've been calculating total scores up to a few minutes ago, but now that we're making the request, we want you to take that pre-processed corpus and include any of the more recent events that have arrived. Again, we're filtering on today's workshop event, and we're going to order it by rank. So let's run this. And I see Taylor Swift is in the lead. Not really too surprising these days. Hulk Hogan. Okay. All right. We got a lot of good players in here. So this is our first node of this, rank games. Let's do, this is, the next node is where some personalization comes into play. And I'm going to call this last game. Oh, didn't mean to do that. Call this one last game. All right. And I'll pull in the sequel for this one. And so what we're doing is we're pulling in that rank. We got the player ID. This is the interesting part down here is we're adding a request parameter to this endpoint, and that parameter is player ID. It defaults to test. I don't know if we have anybody who's used the name test, but what this is going to do, it's going to retrieve the last game for this nominated player. And then let's build our last node, which is going to bring these two things together. Namely, that's bringing back the leaderboard we have of the top 10 players, plus mixing in the last result, the last game for whoever is making the request. So I'm going to call this endpoint again, because this is the one I'm going to publish. And all this node is doing is it's doing a join or a union for the two previous nodes. I'll walk you through that. Another thing to notice here in this node, this is like similar to the one we built, the leaderboard V1 we just built, but notice that it's pulling in from the previous node. So this node is the only one that goes out to pull from our materialized view data source. And this next one pulls from that. And then finally, this one at the bottom, this is where we do a union of all this. Let me particular about my sequel. So here we're doing a select everything from rank games. And also we're joining that with the results from last game. So let me run that. All right, so this is our real version of the leaderboard. Let me create this endpoint. Let me jump out to here. I don't know if I've set these up. Let me see this. Oh, I haven't created that one yet. Let's do this one. Okay, so I'm just proving out in Postman that this API is up and running. We have our ranks here. Let me go back and let's create this other endpoint. So I'm going to build yet a new pipe. I'm just going to call this one get stats. What this one is going to do, it's just going to bring back how many games have been played, how many players have been playing in this session. I'm going to copy this in. And run it, make sure SQL's okay. I'm going to call this endpoint. This is the one and only node. This is the one we're going to publish. Let's walk a little bit through this. So what this is doing is it's going to the user stats table for this event and just counting how many distinct player IDs it finds. It's also going to the events table and looking for game over, indicating how many games have been completed, and then brings those back. So far we've had 14 players playing and they've generated 62 games. So now let's go to our demo. Well, what we have here, again, if you go to the this demo user-facing leaderboard repository, you're going to see in here all kinds of different code for the front-end interface, which I'm going to show here. But first, I'm going to build this and get this compiled. All right, so let's come here. And now we have this leaderboard. So I'm going to put my name in, and that's going to trigger. So here we have this leaderboard. This is a big leaderboard. But what it's showing here, and this is updating in real time. As people play, we're going to see the amount of games increase, etc. Let me now do one other thing. Now I talked about if there was enough time that we would also exercise this leaderboard using a tool called Mockingbird. If you've never heard of Mockingbird, it's a great tool we have where you can basically generate mock data streams. And this can be really an awesome tool for when you're developing with Tinybird. You may want to do some stress testing. Maybe you don't have a data stream readily available at the moment, but you can use this tool to generate something like that. Here, I'm telling this tool, you pick your host wherever your Tinybird workspace is held. You nominate the data source you want to populate. You put in one of your tokens. In this case, I'm using my own admin token. You can specify how many events per second you want to send. This is the schema that you use to generate these events. These are the JSON objects that's created by this tool. Here we have different session IDs that we use, but we also have a list of 1,000 different player names that we're going to be simulating with. And you can come down here and hit a preview just to test that your schema is right. You can see as I click this, it's generating different names. Over the last few days, you can see I've generated a ton of events using this, over or close to 8.5 million. But let's go back to our leaderboard. And here I want to do one thing. Okay, so I don't know if everyone's still playing, but this will be updating in real time. But now we're going to switch gears, and I'm going to go back to, well, first, okay, so there's nothing in there. I'm going to turn on Mockingbird, and we're going to start seeing event stream in here. So I'm starting to stream in events now. But now I'm going to have to do a couple things. One, I'm going to be building off of this new data source. So I need a new materialized view. And it's going to be roughly like the one we just had. So I'm going to duplicate this pipe. And I'm going to call it feed mock user stats MV, kind of a long name. And instead of going to our shared instance, I'm going to pull in these mock events. And okay, so I'm going to run that, make sure that looks good. No data available. Why is that? Oh, I know why. Let me go back to that. We're not filtering on this event anymore. I can just get rid of that where clause. And I'm going to run that. And there we go. I'm going to build a new materialized view that we're going to build this other leaderboard on. Create materialized view. I'm going to call this, what am I going to call this? Mock user stats MV. And I want all the rows there. Okay. Now I'm going to go back to leaderboard. I'm just going to change a few things. One, we're going to change this to mock because we're pulling in all those now. And again, I need to get rid of the where clause because, all right, so we got that. Down here, here, hang on a second. All right, so we got this last game node. I'm going to do this. The joy of live coding. All right, we got that all set. And here we have this. Okay, so we started to have lots of names come in. Let's go back and look at our mocked events, see how many we have in. We already have 15,000. I'm going to go back to Mockingbird and crank this up a little bit. I'm going to stop generating. And now I'm going to set this to 1,000 events per second. That's the beauty of this tool. You want an easy way to stream tons of data. This is a good tool for you. So I'm going to generate this now. All right, so we have lots of data coming in. Let's go back to here. We have this. Let's just make sure this is working. Yes, get stats. I want to change this a little bit. We're going to pull from our mocked users. And once again, we don't need to do the where clause. We're going to do this to, oh, I did that wrong. We want the mock. We want the user stats there because we're counting players. Here, we're going to pull in from the mock game events and run that, see what we got here. Oh, and again, don't need this where clause. So already in that simulation, we've had 7,700 games and we've had 1,000 players. So let's go back to our leaderboard. And again, this will be updating in real time. You can see here, this is the latency for the query to pull in and to calculate the scores. There's another query going on as well about the total number of games. But as we watch this, you're going to see this change in real time. There we just had Carl just got he completed a new game, and it was a top 10 game. You can see my last attempt. I just did a game where I got 9 points, so I almost made the leaderboard. But as you can see, this is updating in real time. We have 1,000 players submitting events at the same time. Collectively, they're sending in 1,000 events at a time. So that's pretty cool. Let's go back here. I just want to see this. So we're already up to 16,000 games. So there, in a nutshell, we have developed a leaderboard that we've seen can handle thousands of concurrent players at the same time. And it's also updated in real time with 1,000 events coming in per second. So I think we've been successful there. So turns out I had plenty of time to walk through really 3 different versions of a leaderboard. And we've been running that leaderboard under 2 different scenarios. So what I'm going to do next is let's walk a little bit through the code. I mentioned before that we just started supporting JSON web tokens in a way that now as a front-end developer, you can make these calls straight from the browser rather than having to go through middleware or a callback to some backend server you have, which then marshals and manages the call to Tinybird. So let's go back to this repository. This is where you're going to find code that exercises these new features. Different places to see it in action. If you go into app, we have this page TypeScript file. Down here, you can see we're setting things up. We're setting this up to call 2 different endpoints, one called leaderboard, one called get stats. Down here, we're building that dashboard. We have different, using different cards here. We have, you can see here, we're using Tremor, by the way. But here's where we actually build what you're seeing here. So you can map that back to that. And then other interesting pieces of code are in the server folder. We have this token, TypeScript. This is the part that's actually doing the signing. So when you make a call, you want to make a call to Tinybird to one of its endpoints. You make a call to this to the server instance. And one key thing here is we're setting up this token to be good for 10 minutes. So these are expiring tokens. You can set them to what time period you want. And also this code, if it has expired, it'll generate a new one on the fly. And that new one, again, will be good for 10 minutes. So that's code worth checking out. Up here in the hooks folder, we have this use fetch class. Here is where we're actually making the call to Tinybird. We're pulling in from the server. We're generating the token there. We're setting up the call to Tinybird. So that's all well and good. And then the last thing to show, I guess, is in utils. Let's go there. And here you have information encapsulated around how do you set up the endpoint URL. This is calling two different URLs. One's called leaderboard, one's called get stats. That's passed in the function call, and then this code takes it from there. So this is a project worth checking out for sure. And again, everything here, there is a short README. It just kind of walks you through how to, you clone this repository. You install Node.js if you haven't already. You need to have version 18 or higher. Of course, you need a Tinybird account. If you haven't set one up, that just takes a few minutes. You don't have to take or put in a credit card. It's good forever. The limitations with the free account are 10 gigabytes of storage at any one time, and you can make up to 1,000 API requests per day. So it's a perfect place for prototyping and designing your API. Anyway, so this walks you through what you should see in the end. I'm on a different branch. This project currently has a couple different branches. We're still adding on different features. Right now, I'm on the player ID branch. This README is reflected on the main branch, where the display is slightly different. So anyway, those are the code features I wanted to show from this project. Highly recommend, if you're interested in these new JSON web tokens, to check this out. If you read the blog post, we also have a even more simple demo that's available. Let's see, maybe this is it. Nope, I take that back. Anyway, if you go to, I guess I could find it on GitHub. Let me go back and show you the more basic demo that shows you just about the JSON web tokens. Yeah, this is the guide that we have. So if you're looking for something that has nothing to do with leaderboards, this one just is a very simple, it calls a single endpoint. The plumbing that I showed you before is the same as this project. In fact, I inherited this project to build the leaderboard example. So this should be a good place to start if you wanted to start checking that out. Again, I want to thank everybody for coming today. We'll have another session on the 20th, and that one's going to focus more on real-time dashboards. That is a huge use case for Tinybird customers. I've mentioned the Vercel dashboard about, any of their customers can go to this dashboard and see up to the second stats about what resources they've used, how many requests have they served, all kinds of great details. And again, we'll be highlighting yet a new feature of Tinybird called Tinybird Charts. It's a neat way to go in and here, I can probably show you at least a teaser for it. If I go into our leaderboard here and I view, oh, no, I'll take that back. See if I can find it. Oh, here we go. So here, when you look at something you've published, this is our leaderboard API or endpoint that we publish. We have this new tag here, this new tab. It's called Charts. You create that, and you can come in here and you can specify all different kinds of different charts. You can pull whatever data you want to pull in. I want to pull in rank, total score. Anyway, you can do all kinds of things like this. But the cool thing in my mind, and this chart, I would tweak this more design-wise for sure. But you can come in here, and then you get this code snippet that you can then take to your JavaScript app and make this call and show that data. So anyway, stay tuned for that. I think that is it for this session. We ended up with 10 minutes to spare. I want to thank you all again for coming. And If you have any questions about building these leaderboards, feel free to reach out to me. My email is jim@tinybird.co, and look forward to seeing you at our next session. So thanks, and have a good Tuesday.